Let's solve today's daily mechanics problem. A car travels on a circular bend of radius of 80 meters. The road is banked at an angle theta, where tangent of theta is equal to 0.3. We need to find the ideal speed so that when there's no friction, it can maintain its circular motion. We first need to draw a free body diagram. So on this car, it'll have force due to gravity downwards and a normal force coming normal from the surface. We can draw components of normal force. So there's one directly in the y direction, which we'll call Fny, and a component in the x direction, Fnx. We can now write our force balances. In the y direction, this gravity and normal force are going to equal, since there's no net force in the y direction, but in the x direction, we have a net force. And since this car is traveling in circular motion, it'll equal the centripetal force, which equals the normal force in the x direction. When you're dealing with an object on an incline, the theta of the incline equals the angle that is on the horizontal from the horizontal force. So when we're finding the normal force in the x direction, we actually have to use sine of theta. So this will equal force normal sine of theta. Now we can set our centripetal forces, which is mass times velocity squared over radius, equal to this force normal sine of theta. Now we don't have an expression for this normal force, but we can find it in the y direction. So in the y direction, the force normal y equals the gravitational force Fg. And Fn in the y direction is going to equal Fn cosine of theta, since it's adjacent to the angle theta. And so now we can break out the force due to gravity as mass times gravity equals Fn cosine of theta. Now all that's left to do is rearrange our equation and substitute in for the normal force. Now we can go ahead and cancel out the masses and rearrange our equation, and we get that the v squared equals the radius times gravity, and this sine over cosine theta just equals tangent of theta. Now all that's left is take the square root and plug in our values. And that's our final answer.